Hello everyone, today we will be going over the systems design course today, and the concept that we are going to be focusing on today is MapReduce queries. So when we're talking about MapReduce in programming model design, we're focusing more on processing large data sets with a parallel distributed algorithm on a cluster. So you're focusing on processing large data sets with a parallel distributed algorithm on a cluster. And the following model for MapReduce querying is based on two main functions. One, the concept of the map, which is to process and transform data coming as an input. And the second part, literally in the name, is reduce, which what they mean by that is aggregate the result. So overall, just giving a technical understanding, in the context of NoSQL databases like MongoDB, namely, and or CouchDB, MapReduce offers a flexible way for a query aggregate data across many documents, filling a gap between declarative query languages and imperative APIs. The strength of MapReduce lies in the ability to distribute data processing tasks across many machines, making it highly scalable and efficient for big data applications. So if I were to give a vivid example, say for instance we're mapping the ocean, to be able to just give a vivid example. If we were to have a large map of data within present time in of itself, it would be beneficial for us to be able to take in the following input data and figure out how that we could actually break that data into various chunks as well. And this is where map reducing actually comes in. So the strength of MapReduce lies in the ability to distribute data processing tasks across many machines instead of just having one, making it highly scalable and efficient overall. So instead of one machine, we have multiple machines processing the input data. I stay right here. So we have a map following input data over here, and we have multiple machines to finally give out our result. As stated in this image over here, notice we have our map reducing. We shuffle out that data. Then we have our given machines as well to also aggregate our final result. And so unlike traditional SQL queries, MapReduce operations involve writing snippets of code that the database executes. And this allows for complex data processing and aggregation that might be cumbersome or inefficient with just a standard SQL. So put this right here. MapReduce is efficient for no SQL applications. And again, as stated before, mapping with the ocean, we'll take the example even further of taking marine biologists tracking shark sightings across months and would like to utilize MapReduce to aggregate observations by month, summing up the total number of sightings. So EX, marine biologist, summing up all shark sightings per month. So overall, despite its falling power, MapReduce operates at a fairly low level of abstraction, requiring developers to write specific functions for mapping and reducing data. So this really comes in with writing functions to map and reduce data. This can include complexity and potential for error, especially when coordinating these functions for complex queries. Moreover, the model enforces purity in these functions, and they cannot perform additional database queries or have side effects, ensuring reliability and predictability in distributed environments. So interestingly, as NoSQL databases evolve, they often reintroduce SQL-like query capabilities. So for instance, MongoDB added the aggregation pipeline. So I'm just going to put this as a side note. Added aggregation pipeline in order to have a more declarative way to query data that resembles SQL's expressiveness and way more and a stated comfort for relational databases as well. But it's interesting enough that they rely on JSON-based syntax, which is great for document databases as well. So relying on JSON data. And this following evolution suggests that while MapReduce is powerful for distributed data processing, there is still a continual need for more simpler and more intuitive query languages. Even in the NoSQL system, eventually there'll be something that will be able to not only just be able to handle complex modes of data and how it's going to be processed in real time, but also there's obviously going to be updates with further languages as well. And that's where you come in. And this is also why you're doing this course. So let me just zoom out to be able to help cement this concept right here. And feel free to take a screenshot of this, and we'll head over to our concept example with some JavaScript. So now to be able to solidify our understanding of map queries, let's go over a concept example. So now let's imagine we're a marine biologist using a database to track shark sightings. Every time we see or observe a shark, we need to record the following. So we need to record the date, species, and number of sharks seen. We wish to compile the data into a monthly report that indicates how many sharks have been sighted per month. So we are doing a monthly report for sharks sighted per month. And ultimately what we are doing, and there's already a JavaScript that is already a script that has already been made, and so we're just going to be breaking down over what has already been made to go further in depth. And so overall what we are doing is that the following code is made to be able to store the following values in a key value relationship. But to break down over what we have, so we are tracking the sharks per month, and we're actually just keeping track per year and month as well. And what we are doing is that inside of our function map, we are emanating a key value pair where the key is the string consisting of the year and month of the observation. So year and month are strings. Right over here. And we're storing the instances whenever we observed. And the value is therefore the number of animals observed. So this is the key, and the value equals the number of sharks observed. And the reduce function that we see over here sums up the number of sharks observed for each key, producing a total count per month. And it is set up in an array with the sum of the following values, hence the key value that we already set up in place right here as the parameters. We have the values over here. And so if we wanted to, in particular, run through this, the result is stored in a new collection called monthly shark report. That is our output. This is our query that we have for the number for sharks. It goes through the following functions that we have and then returns the value that we already set in place whenever we call upon our MapReduce function. So let's just go out here. There we go. Let me just fix this. All right. All right. So feel free to take a screenshot of this. And we'll move over to our practice problem. Now, to be able to go for our practice problem, we are given the following scenario. We have a database where we are observing marine life across several years, including sharks, dolphins, and whales. We need to generate a report detailing the number of dolphin sightings per month. So it's just in the context of dolphin sightings. And so what we need to do for our following steps, and I also have the JavaScript function over here, and we'll be able to go further in depth, but to give over the steps is that one, we need to write the map function. Two, we need to adjust the reduce function. And three, we also need to modify the query parameter. And so within our following JavaScript code that we have, when we adapt the map function to filter the observations, we're focusing on filtering the observations for dolphins. This involves checking the family attribute right over here, and of each document and emitting the year month key along with the count of number of dolphins observed. So since we are going throughout the rest of the animals, all we need to do really for the most part is similar to what we already did in the first concept example, except for we're just dealing with dolphins in this case. So it's just modifying the parameter, and all we need to do within the key value pair is we just need to simply change just the family of the dolphins over here to assess between just the number of animals and assessing between our string values of year and month. And when we adjust the reduce function overall, since we are using the same type of example that we have did in the previous concept example, there are no changes necessary. So we just move over to the parameters. For the reduce function, gives us our output. We set it up for our desired output. And all we have to do for the query parameter is we just literally did it right here. So very easy, very simple to do. And any cases for queries and databases, they're relatively straightforward, and they can also be redundant and reused as well for both document and relational databases. So let's just zoom out over here, and you can take a screenshot of practice problem number 1. And now let's go over our second practice problem. So in our second practice problem, we're given the task, which we will break down the following operation that we already have over here, where we are doing the same thing, except the key differences is that we are going to be focusing on the extraction of whales in this case. So what we will be doing is that in our scenario, we're focusing on generating a detailed report of whale sightings grouped by species and quarter. So focusing on whale sightings. By species and per quarter. Where a quarter is going to be 3 months. And overall, what we will be doing is that we will be extracting our JavaScript code that will be used for MongoDB and break it down how we get set up our following operations. So let me just expand this even more. All right, so going back from what we have done previously, as usual, what we will be doing is that we're going to be focusing on 1, the map function, 2nd, the reduce function, query filter, and finally our output. Just keep all the code together. And so within our map function, what we're doing is that the function is executed once for each document, in this case, each whale sighting, that matches a specific query. It constructs a composite key from the year, since we are using a string in this case, and quarter as well, calculated each month. So that means that we are doing a month, then this is our quarter over here, hence the variable. Then this is our key, and MapReduce functions like this do a key value pair, where the key is pertaining to the time, and the value is a number of sightings. The number of sightings. And so the key is used to group the sightings. Well, the function then emits the key along with the value of 1 to signify a single sighting. So we have key, and this is how we initialize for each sighting that we have, and then we regroup them together. And then for our next reduce function, we sum up all the sightings for each key that we have. And so our reduce function calls a function once for each unique key element by the map. Calls for each unique key element per map. And for the map function, I'm going to say we initialize our string variables for a key value pair. As specified by the key of the time, the value of the number of sightings. Then we will be doing a query filter depending on what we are getting, and similar with our parameter, we put in whales as what we want to get. And then we have our output, a quarterly whale report, as specified by our following output. It's collecting the total representative sightings of whales. So we are outputting total collection of sightings of whales for a report. Query filter, we just filter by parameter. Of what we want. There we go. And overall, this MapReduce operation provides a powerful tool for aggregating large sets of data across distributed systems, especially when dealing with complex grouping and summarizing tasks like this one. So let me just zoom out. And then again, feel free to take a screenshot of the following as well. Let me just fix this and then make this bigger for you folks. Let's fix this up. 4 over here, 3 over here. There we go. And so, yeah, this was a video on MapReduce queries. Thanks again for taking time to watch this. If you found this video helpful, be sure and feel free to like and subscribe. If you have any other questions or queries, feel free to put them in the comments section. And as always, take care. Cheers. Bye-bye.